Okay, so I do have to call you Sir Alfred, or not Sir Alfred.
There's no sirs in the room.
There's no. So we were just saying. So Nobel Fire Systems.
Yes.
And linked somehow to the Nobel Peace Prize.
It does indeed. Yeah, we have a long history dating back to 1874, and our name comes from Sir Alfred Nobel, who built the first explosive site in the UK, which was based up in Scotland, and that, as it progressed, became part of ICI in the 1920s.
Oh, the guys who do the paint, like the Dulux paints.
Yes.
Yeah. Okay.
Yes. So the Imperial Chemical Industry took over the Nobel name, and Nobel still exists now to manufacture energetic technologies and nitrocellulose products and any kind of products to do with paints and thinners. But there's a big part of their business which is explosives and energetic technology, so like airbags.
Energetic technology. What an exciting thing to say.
It is. It can be quite a frightening thing, but when you work with it and you can control those explosions into production of gas, they become very useful tools to displace liquids, powders, chemicals, and things like that.
Right. Okay. So we're talking explosions, big bangs, booms, hissing.
There's no bangs in fire protection.
Sorry, that's the thing we're trying to avoid, right?
Quite the opposite. Yeah.
Okay. I'm here with Ian Bartle. Hello, everybody who's watching or listening. We are today going to talk about one of those things in energy storage, which is sort of talked about, but perhaps not enough.
Yeah.
So we're talking about explosions, fire. We're talking about what happens to all this energy in energy storage if bad things happen, and how we design systems that are safe. And safe is a very strong word, and I'm not going to say that loosely. Yeah. We've got Ian Bartle in from Nobel Fire Solutions, or Fire Systems. And you guys have been doing stuff to do with fire protection for energy storage for a long, long time, right?
Yeah.
And so what we want to find out today is what's the risk? How is it being managed at the moment?
Yeah.
And what do we need to think about, or what language do we use when we're thinking and talking about this stuff?
Okay.
But before we get started, Ian, thanks for coming. We're in Modo HQ. We're in Birmingham. Who are you, and how on earth did you get into fire stuff?
Yeah, why am I here?
Is there a poll involved somewhere?
There is a poll.
There is a poll. Okay,
yes.
right.
There is a poll involved.
Yeah, and a pool table.
Yeah. Yeah, there is, and spoiled lunches and things like
that.
But my background is I've been in fire protection now, and what you would term special risk fire protection for over 30 years, although you can't really tell. But yeah, my background is in engineering, and I was in mechanical production and design engineering. And while I was doing that, I joined the fire service. I was part of Lancashire Fire Service for 12 years as a retained firefighter. So it was good to get an appreciation of the sharp end of fire protection and what fire services are presented with when they do arrive at an incident. So over that time,
to be clear, we're talking about going around in a fire engine and putting out fires.
I was part of a main frontline fire station with several pumps, and I've been on some enormous 30 pump fires down to single fires, car crashes, you name it. If it's out there, I've been on it.
There's a whole podcast here, and you must have seen a lot, right?
It's been phenomenal experience, and the guys in the fire service do such a phenomenal job. And they're being faced with this new risk.
Yeah.
So going back 30 odd years ago, what I did, I combined my engineering qualifications with the fire side and decided to get into what you would term special risk fire engineering. So what that encompasses really is you get specialists in fire detection, which will do general fire detection within a building, and then you might get a sprinkler company that dedicate themselves to the active fire suppression side. So you've got the detection system that will evacuate the building, and then the sprinklers that will actually do something about the fire as it develops. So my fascination and my preference is to get into the active side of firefighting, and I've worked for a number of companies before I decided to go self-employed, which was 30 years ago. And we started to, or should I say, when I started on my own, I started to sell products. So I was involved in selling specialist products to other fire companies, but those fire companies started to ask me if I wanted to install the products I was selling to them. So it became a case of, yes, I can, and the expansion from that was incremental. We're now in a position where we've 40-odd employees, and been in business as Nobel Fire Systems for the last 20 years, but dedicated really to anything that doesn't involve just detection on its own or just sprinklers on its own. So we'll look at...
So more complex systems.
Yeah, they tend to be things that don't naturally suit water as a extinguishing medium. So that it could be that there's a dry medium required or a gas system required or some other form of suppression agent that's better for that risk.
Which is why batteries, of course, because we've got for background, we've got a lot of systems out there in the UK. I think a lot of gas, FM200 and other types of gases.
Yeah.
We've got some water sprinkler systems.
We've
got some powder systems. We've got all sorts out there in the UK.
Yeah.
And what we're going to find out today is what is the correct one, Ian? No, of course there is no correct answer.
That's very true. Yeah.
But yeah, what we want to find out today is what's out there and what should people be thinking about, because a lot of folks listening to this are involved in the value chain of energy storage, building, operating, developing, financing.
Yeah.
And really early on in that journey, it's probably a good idea to think about what is the right system. So coming back to Nobel and you, what have you done in energy storage? What's the background of your company in energy storage and what have you learned along the way? And then we'll dig into some of the details. And just to get it in there early, we need to talk about thermal runaway.
Okay.
So,
yeah.
But what have you done in storage?
Well, it's been quite wide ranging. We've worked on very small systems from single rack enclosures up to 50 megawatt, and we're now involved in more on the consultative side and in the early development strategies of combined systems. So it's looking to how we prevent thermal runaway in the first instance, and I think it's worth just focusing on what thermal runaway is. And there's different...
It's a terrifying set of words to put together.
It is, especially in the context of we need to keep this place up and running.
Yeah.
So there are certain aspects of what we offer have certain attributes that we're looking for different phases of fire development. So in the early instances, when you get, before thermal runaway, you get a small window of opportunity to detect a developing incident. And we have specific products that will detect the off gas before thermal runaway starts.
So for layman terms, we're saying, you're talking about different phases, right? Which is fire hasn't happened yet.
Yeah.
Fire's going to happen.
Yeah.
Fire's happened, but it's small and you can do something about it. Fire's happened and it's all over, right? You can't stop this thing.
Yeah,
and then fire's happened, it's over.
Yes, it is.
Right, okay.
It is exactly that. And prevention is always better than the cure.
Yeah.
So part of our strategy is really to understand the engineered environment in which we're going, because while some are modular, some are building systems, some are a small quantity of racks, and some are rack after rack after rack. So really, our preference is to get involved early on in the process, as well as hopefully involving insurers and anybody else that has an interest in where this might be. So it might be local county councils. Where's this best system going in a building? Is it in a field? And all of these parameters will form a picture of how best to protect it. Because as a fire company, you can have 1 million products in there, but it gets too expensive and too unwieldy to operate.
Well, before, can we take a step back a second?
Yeah.
I want to ask you, this may sound like a basic question, but what is a battery fire?
Okay.
Define a battery fire.
Okay, so each pack is made up of a small modules of batteries, so it might be an individual cell or pouch. So when you get thermal runaway, what happens is there's an increase in temperature in an individual cell or battery module. And that it's a chemical reaction within the battery, but it's self-sustaining. And it's that vicious cycle of temperature, increases temperature, and you get to a point within that cycle that there's a point of no return. All the materials start to break down inside the battery, and then you get a big release of heat, and then you get your fire situation.
So this is just heat now. We're not talking about ignition yet, are we?
In the testing that we've seen, there's lots of different reactions. When you do fire testing to prove a fire system, you use, say, a single material which will establish performance criteria. So you know against another product or another type of nozzle whether your suppression medium is effective at a certain density on a certain size of fire. And that's usually heptane if you're testing foams or dry powders, because it burns consistently from country to country, from test authority to test authority.
Sorry, we have to simplify this because I'm lost already, right? So
I've
got no idea what a heptane is or whatever. It sounds like what you're saying when you're testing, when you're testing the performance of systems under fire conditions.
Yeah.
You can use a load of different ways to test for it. Is that what you're saying?
There is. Depending on your suppression medium and what the risk is, there will be a material that you can test. You can fire performance test the system. So you know how much to put on that fire and at what rate for it to go out.
Oh, okay. So we're on to putting fires out now.
Yeah.
So if we go back to a cell catching fire. So a lithium-ion cell, for example, which is about the size of... What have I got around here? It's about the size of this Louis Theroux. We've got to get through this book, right? And that's full of a pouch of electrolyte, and an anode and a cathode.
Yeah.
And that thing catches. So that thing gets very hot.
Yeah.
And then it catches fire.
Yes.
And then what's actually burning? Is it material? Is it gas?
Very early on? It's a Class D fire, but that is momentary. And then it becomes a...
What's Class D?
Class D is a metal fire. Okay. But it is momentary.
Metal fire. Yeah. This is like Lord of the Rings stuff.
Well, the thing is, these fires are self-sustaining. They produce their own oxygen and gases. And because of the temperature increase, they're very difficult to put out. And every suppression medium finds it very difficult to get the right quantity in the right place for the right amount of time to be as effective as they could be. So that production of gas, which is the first element, which feeds the fire, creates that.
So the cell gets hot, creates gas.
Yeah.
The gas burns, gets hotter, creates more gas, gets burned.
And then you have the knock-on effect to the other cells adjacent to it.
And then it's go time.
Yes.
And then we're making a lot of noise.
And the reason for mentioning heptane and things like that, there's not one battery that will burn the same when you ignite it. So you can get it to ignition point by overcharge, by mechanical abuse. But it's usually done through the thermal overloads induced by increased current. So you're putting too much current into it, that gets hot, and then the process of thermal runaway occurs.
So the risk we're talking about here is we have grid scale batteries which are full of small cells.
Yeah.
And those cells, if they do catch fire, you can get into a situation where they will keep on the fire will get bigger and bigger and bigger until something intervenes.
Yes.
Or until the fire goes out.
Yeah.
And that's the thing we talk about thermal runaway. That's the thing that's scary.
That's the frightening thing.
And why is that different to other fires? Why is that why is that a different category of fire to other fires?
Okay.
Or is it not?
It is to a degree, and the main reason for that is because it is a self-sustaining fire, and because the batteries are deep-seated. Normally, if you get a fire...
What does that mean, sorry?
If you get a fire in an office, it's a surface fire. So when you walk into a room, you can see where the source of that fire is, and a firefighter can direct a jet of water onto it to put it out. But when you've got a rack, you've got a module made up of batteries. So every time you put that cell inside something, it's another barrier to the fire suppression.
Okay.
So that's the deep-seated nature. So it will continue burning until you can get fire suppressant agent or liquids onto it.
Okay.
So it tends to be a catastrophic fire because battery technology is very safe, but when they do happen, it tends to be a big fire rather than a small smouldering fire that you can deal with.
This is the funny thing, right? We're talking about, it's very scary.
Yeah.
But then again, we've got to put this into perspective. The benefit of batteries are, we basically need them for the renewable energy transition that we need. Like there is no renewable energy a world to live in without batteries helping. So we need them.
Yeah.
And then operationally, actually, we've got many gigawatt hours. I don't know. Someone's going to tell me what this is, but maybe hundreds of gigawatt hours. I might sound silly saying that, around the world installed, and very few fires.
Yes.
Right? I don't know. You see about the odd one here and there, but it's not all the time.
No.
And so I guess we need to balance that risk, and it is very scary, but also it's like an outside black swanny kind of event. And then what can we do to prevent? So I want to talk about prevention, and I'm going to get my words wrong here, but how do we stop the fires from happening? So prevention.
Yeah.
And then how do we put the fires out? So
Okay.
let's do the prevention one first.
Yeah.
Because that seems like the most sensible.
The sensible option is make sure the fire doesn't start in the first instance.
Yes.
And if we can
No
do
smoking
that,
in bed.
Yes. So the best method of doing that is to have a dedicated device, and there's different types of lots of different types of detection device, and we're looking for different things. Typically in a building you'll have smoke detectors or heat detectors. But with lithium-ion batteries, the very first telltale signs you get prior to thermal runaway is an off gas. So it produces very specific number of gases before it goes into an uncontrolled situation. So we have a detector very specific for that,
Just sniffing for those gases.
Sniffing for that gas. Yeah. And what we do then is the control devices that's attached to provide a signal for shutdown.
Okay.
And what's been seen to happen in all of the testing is that when you isolate the battery from either charging or discharging, that temperature drops.
Yes.
So you avoid thermal runaway.
So we've got a big measurement device, a big nose sniffing for a gas.
Yeah.
And when it smells it switches everything off.
Yes.
And there you go. Fire.
Yeah, it's a case of isolate and alarm. So you've got to have, it needs attention, so you need engineers to attend. But it's very unlikely in that situation you would need attendance of local fire authorities and things like that.
One thing I must mention here is we've gone straight into active prevention.
Yeah.
But there's a more, it sounds like I know what I'm talking about here even, doesn't it? Wow.
You're convincing me.
Wow. I'm an expert. No, things like design, right? Materials design, cell design, firewalls,
yes.
distances, separation, all that stuff which happens before you even get on site, right?
Yes.
So let's probably skip that for now. Let's go straight into the more exciting sniffing mode. But we must give a shout out to all the people out there who are designing systems properly in the first place.
Yeah,
right?
the segregation is so important.
Segregation, there you go. Yeah. And so, okay, so we've got we're sniffing for off gas. What else can we do?
Well, because we don't know what kind of reaction that lithium-ion battery is going to have, it can either just produce gas and once you've isolated power, stop. But there are slim chances, and there are slim chances of that thermal runaway still continuing because it's a chemical process and it's already reached its point of no return, and away it goes into the disaster side. So what we've got to then do is there's a next phase of detection, and that's a production of heat and visible smokes.
Okay.
So we have a combination of detectors, so we don't get false alarms and spurious releases of systems. We have a combination of detection that will analyse the environment it's in. So you get a first stage alarm saying there's a fire condition in here, but it's just smoke, and then we get heat. And that
so infrared
heat
kind of thing.
It's more of a thermal, because the heat ray rises quick. We tend to go off a change in temperature in the risk that it's in. So it might be the actual cabinet that those batteries are sat in, and we have anything from spot detectors to linear heat sensors that we can run around the risk. Again, it depends on the format of the build of batteries and how what the best units like. But again, that's a choice of an engineering response to a risk. Because we've got so many things and parameters that we can that we need to take into consideration. But at that point, you know it's definitively going to go into thermal runaway and a fire is imminent. So it could explode if the temperature and gas production's too high, or it might just fizzle into a progressive fire through the battery
question
module.
here, right? So like a campfire. This is
Yeah.
Campfire burns quite safe, really.
Yes.
And there's a few little puffs that come off it, but you can toast your marshmallows. All right?
Yeah.
Now, I remember the Galaxy Note phone. I don't really remember that.
Yeah.
They were like, it had I'm going off on a tangent here, but didn't that? I remember being on planes where people were saying, if you've got a Galaxy Note, you need to tell us now.
Yes.
For a few weeks, whatever.
Not in your luggage. And,
because the pouches were catching fire, whatever it was, the lithium-ion, the electrolyte pouch in the battery, because they'd designed it too thinly or something. But the interesting thing about that is, I really am going off on a tangent here, but that was all about explosions and projectiles, and it didn't look like a campfire, right? It was like bam, pop, fizz, pos, blah, blah, blah.
Yeah.
The audio is probably not going to sound good after that. But I guess what are we talking about here with lithium-ion cells? Are we talking about fire, heat, smoke, smells, like residue? I don't know. I'm not a fire guy.
It's the combination of all of those, but it's the very high temperatures that are involved, because the materials that are involved burn at high temperatures, but it's also, as they burn, they produce explosive gases, and it's those explosive gases that can make the whole environment that the battery's in a dangerous environment to actually go into. And certainly the incidents that have been in Texas and certainly in Liverpool just recently, there have been elements where there have been explosive gas releases. So you will see BESS modules now being made with explosion panels.
Yeah.
And
it's just in the containers.
It is, yes, yeah. So it's localized to whatever. When you get an enclosure and an increase in pressure, you've got to design in a weak point so that you know where the force from that blast is going to go, and it's usually upwards and out the way.
Because a lot of the cells have got over. A lot of the cells. So I know when I was at Centrica and we built Roosecote, which was in 2017, which was big back then. It's 50 megawatts built in a building. They don't build them like that anymore. Magnificent thing, I must say. And that was Samsung SDI cells, and they had loads of things. So they had like overpressure. The cells themselves.
The cells themselves have a lot of
overpressure safety. You could put a nail through them, and they were safe.
Yeah.
They had They were designed to pop in certain ways mechanically. Very, very well designed. I guess there's a nod here to the cell manufacturers who are also putting these things in place too.
The design, we were going to see over the next 10 years such a radical change in battery density, physical size, temperatures, and people are already muting the no-fire battery technology. We don't really believe there ever will be, because even the batteries that say won't set on fire are setting on fire.
Yeah.
We're seeing the 2 buses in Paris recently in what was supposedly classed as non-fire batteries burning quite happily.
But there is an element of it. So the funny, there's probably a clever way to describe this, but it's like a sampling thing, right? Because the more that we have, the more electric vehicles get built, there's a bigger sample for fires to happen.
Yes.
And so there's more fires in the news, and your brain thinks, oh, there's more lithium-ion battery fires.
Yeah.
But there are more fires, but there's also way more lithium-ion batteries out there, right?
Oh.
So they might be getting safer, but because you only hear about the worst case scenario and there's more of them about, then you kind of there's like a bias in your head where you think there's more of them.
It makes the news.
It makes the news.
It does make the news because the main reason is because they're usually more newsworthy. The fire in Australia that recently, where you could see one 40-foot container burning quite merrily in the middle of another 40 or 50 containers. It makes great news because there's lots of fire engines, lots of water being squirted.
Yeah.
But it was contained.
So the one container didn't spread to the other containers?
No.
Fantastic.
It was Fire Brigade did a wonderful job of getting the fire surrounded, getting cooling water onto everything, and then it's a case of managing it as an incident for its duration of whatever it might be.
Yeah.
And the batteries, even if you've extinguished them, have the potential to reignite maybe 48 hours later, a week later, when they're sat there in a safe location.
Wow.
So
Didn't know that.
Yeah, it's probably the different technologies there are of batteries, but certain technologies have an ability to do that. So.
Well, I guess we should say here, we're just talking about lithium-ion batteries, right? We're not talking about vanadium flow or other systems.
I think any that is batteries, that technologies that we're seeing in BESS units today, be they lithium iron phosphate or the earlier lithium ion type of batteries. I don't profess to be a chemist, but from our perspective, we would treat them the same way because they're surrounded by combustible materials. So whatever happens when that battery sets on fire, it's going to take control gear with it, cabling with it, all sorts of things that surround it. So we've got to consider the source of the risk and try and... So with fire suppression, you're trying to stop the growth. So you're looking at containment first to try and stop that propagation from one rack to another, from one cell to another. And when it's in the deep-seated nature and it's difficult to get your suppressant in there, you end up with a bigger fire. So it becomes more of a long-term containment. And insurance companies obviously want to see things up, minimum damage, and as back up and running as fast as possible. But with the nature of the risk as a whole, you're dealing with a fire that is always going to progress into a bigger fire.
Yeah.
So the suppression mediums have to be designed to try and contain it for as long a possible period to allow cool down and the propagation from one cell to the next.
Yeah, okay, makes sense. I guess on a high level, just one thing that just occurred to me is, without getting into the detail, that all parts of the legacy energy system have got fire risk too. So, when I worked offshore in gas platforms, for example, you're basically sitting on a massive compressed bit of gas, right? Where you're trying to reduce ignition sources.
Yeah.
Same with oil. Same with power generation, with coal units and gas units.
Yeah.
So whichever... I don't know why I'm making the case so hard for renewables here. I feel like I need to put...
we have to say that it is a very safe technology.
I don't know why I'm doing this. I don't know. I'm just trying to make the point. I don't know. I'm getting defensive here, right? Anyway, so we talked a little bit about... It's a bit like what they teach you at school, where you have to sort of smell for gas and then put the back of your hand on the back of the door to see whether it's hot.
Yeah, whether the door's hot.
Which is basically what you guys are doing with sensors.
Yeah.
What about when there is a fire? How do you put a fire out on a battery system?
Okay.
Let's talk about, for example, a 40-foot container filled with lithium-ion batteries. Let's not say LFP or NMC or any of that stuff, but just a normal, standard, run-of-the-mill 40-foot container full of batteries, and we have a fire in a cell.
Yeah. And
it's going to spread. Now, A, how do you put the fire out? What are the options? Yeah. And B, what are the fire department, fire Americanism say about it?
Yeah. Well, and the
insurers. There's a big question there. Sorry, let's do it.
Yeah. I mean, insurers have a bigger part to play and should be consulted very early in the process. So when you're applying for planning permission, all the rest of it, really it's to get in bed with an insurer, because they will, at the end of the day, have to carry a can for the risk, and it's going to be their cost. So they'll have a preset way of doing things in their mind. So, and because these fires burn hot, the process is to cool. So we're looking at, if you can reduce the temperature, you reduce the fire size, and you will get, ultimately, once these cells burn out, because there's probably very little that can stop them from burning, once they burn out, it's a cooling process, and it's more of a containment than suppression and extinguishing.
But let's take that kind of disagrees with something I thought, but I'm probably wrong. You're the expert. But we've got containers out there that have got gas suppression systems, right?
Yeah.
A big gas container, a bit like a handy gas thing, but a thinner one.
Yeah.
That's got nozzles that will fill the container with gas if there's a fire.
Yeah.
But that gas doesn't cool it, right?
There's a couple of chemical gases that will, but they don't cool it sufficiently enough. So our advice would be not to use those gases.
Really?
Yeah.
So your advice is not to use gases in containers?
There are some gases that are fine, but certainly we've seen in the field certain gases, and I don't want to name them because it's not the right thing to do, but there are certain gases that are being used that will fight the fire in the cables and electrics fine, but won't have any effect at all on the lithium-ion batteries.
Okay, interesting. So what do you say instead? Should people be... I know we said there's a different answer for different systems.
Yeah.
But my intuition, was, and it changed a little bit, was that electrical fires you shouldn't use water on. That's my gut feeling, right? Because electric and water don't mix.
It's the very basics of,
I know of a number of systems out there they've got big fire tanks on, the planning commission's gone in, they've got massive fire water tanks, they've got sprinkler systems, and they were advised to do that by fire consultants.
Yeah.
So does that mean that the water systems are a good option?
In short, yes.
Right, okay.
Because it's what we're looking to try and do is prevent that fire from affecting other parts of the facility. Mm-hmm. So what you're looking to do is cool and contain. So sprinklers, by their very nature, you might find this surprising, but they're not designed to put fires out.
Oh, right.
No, they're designed to contain a fire and stop it where it's propagating from. So when you go into a building, especially if you go into a factory fire that's on fire and the sprinklers are operating, you'll very closely see that the source of that fire, if it's big enough, will be surrounded by active sprinklers and it'll be retaining it in its place. The fire may be too large for a single sprinkler to deal with, but it's not progressing through the building, so it becomes manageable. So the water element that we're trying to use on BESS systems is there specifically for that purpose. It's to cool, manage and contain, with possibly the added benefit of it extinguishing because it's cooled sufficiently.
What about cost?
Cost.
Right? So I asked you loads of questions and I didn't get all the answers, but that's my own fault for asking you 5 questions in one. But I want to jump to cost now.
Yeah.
So is gas or water, or gas or liquid, I assume it's all water, I assume it's like ionized or something like that, is it?
It won't be, because when you deionize water, it becomes unbalanced, so it's looking for those... so it'll rebalance itself when it comes into touch with things.
So, sorry, I got technical there. So, water or gas, which is more expensive?
I would say, that's a good question. It depends how you configure them. But if you're on small modular systems, say if you were on 140-foot container, it's going to be cheaper to put gas in. Mm-hmm. Or we have a product that's a condensed aerosol, which has gone through all sorts of testing to say, yes, it can hold back, contain and extinguish lithium-ion batteries. So we tend to put our irons in one fire, so to speak.
Oh, so you guys do sell or install or design gas systems on batteries?
We have
so
an option.
So it's not all gas is bad and all water is good?
No, it isn't.
Right.
We have lots of different gases that can be chosen, and we can pick from any range of gases. They may be inert gas, they may be chemical gases, CO2 is no good in this sort of
some of them are quite nasty, aren't they? If you're going to put a fire out, I imagine you don't want to breathe it.
Well, we've got to, in all of what we're doing, consider the environmental impact of what we're doing as well. Because when you do put a lot of water on these, you get fire water runoff.
Only got contamination from...
Yes. Yeah. So it could be, if you've got water courses close to it, or drains, that all of that contaminated water is going to end up into the environment, so the EHO will come down on you. And
so you need to bund it, put it in a big swimming pool kind of thing.
There may be areas and sumps that you can put in place that will contain an element of water. So we tend to err for, rather than sprinklers, which may use 100 litres per minute from one head, for water mist that would use 10%.
100 litres a minute from one head. So it's like...
at the minimum.
Right, okay.
So if you have
I'm trying to figure out what that looks like.
You've got...
Well, it's almost a 2 litre bottle of Coke every second.
Yes. Yeah, it is.
I'm thinking 2 litre. Or if you get the ones from Pizza Hut and they give you 1.5 litres or 1.25, it's kind of one of those, isn't it? Every second. Right, it's a lot.
It's a lot of water. Yeah. And the problem with sprinklers is they're very good at containment, and that's why they're being used. But the vast majority ends up on the floor and running out, and not on the fire itself. So it's acting to cool the surrounding area very well, but what we're trying to do with water mist is utilise water better and get more of water's capabilities for heat absorption from it.
So
and that's all about
surface area,
reducing droplets. Surface area, that's the key.
Okay.
Yeah.
So we've talked about gas a little bit. We've talked about water. I'm sure we could talk about this for hours, but I want to talk about insurers. And then what did the fire service say?
Yeah.
You know, you and I own a nice big battery somewhere. We're very happy with it, and then it catches fire. And we call... Do we have a button? I don't know. Maybe do we have a button?
It would be an automated response, a bit
Right,
like
okay.
you get from a building now. So there may be an automated alarm, and you get what they call a predetermined attendance of fire engines, which will probably, at the best site, at least 3 or 4.
Oh, right. So this is really exciting.
Yeah. You know that you're going to have a response, but depending on where this is, it could be in city centre, in a building, in a basement, or on a roof. Or it could be in a farm that's 20 or 30 minutes away from somewhere.
Yeah. So for ours, it's probably outside a building or next to a big substation in the middle of nowhere, which is, I guess, is a good thing. You want to be in the middle of nowhere.
Yeah.
So in come the blues and twos, if you like. This is all. Like the 5-year-old me is already really excited about 4 fire engines turning up, and then all your bods turn up with their gear, and then what do?
First thing they do, stand back, make an assessment of the risk. What they'll have done prior to that is they'll have made themselves and local crews aware of what risk they're coming to. So on their attendance, they'll get information, fire at such and such a place, so they know it is a best risk. They know they're going into a sticky situation. And unless there is a life risk where they need to make a rescue, they're going to stand back, carry out a good risk assessment, and then look to contain that fire. They're not going to want to make an entry into there where they can put themselves at risk. So life is paramount and capital cost is second.
Yeah.
And then they've got to think...
Even though we mortgaged our houses to build this battery, they're still not going in there.
No. But there's no life risk, so I think there's a growing attitude that it should be the responsibility of the people that are building it to take care of their fire risk and supplement it by local fire authority, because they're not deemed as experts in this type of risk. So they go into an active fire, and the only medium they've got to put that fire out is water.
Yeah.
So they're going to stand back and they're going to surround it and pour water on to the other best units around it to save
stop
them.
them catching.
Yeah.
All right.
And that's going to be allowed to burn out.
That feels good. So we might lose 1 container out of 40. Which
yeah,
means
and I think that's how insurers are looking at it.
Yeah.
They are saying, right, okay, what can we afford to lose as a risk? And that kind of meters the protection levels.
It's quite nice, actually. So one of the effects of building batteries in shipping containers, which in itself,
is a
and
lovely
I've said it a few times, but you know, if you'd asked you 10 years ago, we're going to build grid scale batteries, and someone said we're going to put them in shipping containers, I probably would have thought it was silly.
Yeah.
But anyway, they're everywhere, and there's a load of really good reasons for that. But one of the additional good reasons is that you can put them distance apart from each other, right?
Yes.
So you get a fire in a container.
You get great separation.
Which is good. Which is good.
Yeah, and natural steel walls that will take some doors may be blown off, or explosion panels may have been dislodged.
There's a John Cain bit we need to kind of put in here, but yeah.
But at least it gives the fire service
not John Cain, Michael Caine. Michael Caine.
You're
only supposed to blow the bloody
there you go.
off.
Yeah.
Paul Caine. What was that? What am I on about?
He's a friend of his, don't worry.
Oh, yeah. Anyway, so doors might be blown off. That sounds very exciting too.
Yeah.
Don't want to get in the way of that.
Yeah.
But you've got some separation. What about, we talked about insurers for a moment, but bringing all this together, what would be your advice to people who aren't fire experts, perhaps in the investment community, who want to get into this asset class, want to build these assets, see the huge societal benefit of them?
Yeah.
What should they be doing to... What's your advice?
I think the best starting block is to involve very early people that have an interest in the site. So that would be local fire authority who have to have a say because they're attending, and in particular get to know the insurers and their attitude to that risk. And then what you can do is the fire service will feed in safe roads into it, so they've got access points and safe areas to work in depending on the wind and air environmental conditions. But the insurers will say, okay, they'll quantify the risk levels, and that might be based on a lot of different things. And it could be the internal structure and build and format of the BESS, the battery technology, and also the cabling and grid connections, and whether it's...
Is there a standard? You know, if I'm investing in it, if I want to own one of these batteries, can I, in due diligence, can I say, you know, has it been built to standard X112 or whatever, which means that from an insurance perspective, we're comfortable, let's take an adequate precaution against fire?
I think this is where some of the difficulties lie, in there isn't one universal standard that everybody can refer back to. So what we tend to do with fire systems, we look at British standards or UL standards, which is a universal US Underwriters Laboratory standard that people can look at and say, right, this is my marker in the sand. And we're starting to see them develop and come through, and which is what the whole industry needs. And there are two standout guidelines at the moment, NFPA 855, which is a guidance document and best practice.
NFPA, I'm going to take a stab at it. National Fire Protection Association. Boom! Boom! That's made my day.
But the one that has more teeth.
Oh, come on.
And has
it got an acronym?
Yeah, it's UL 9540A.
So I forget the numbers. Oh, there's a letter on the A on the end.
Yeah, and I have no idea what the A stands for.
Universal. No.
Well, Underwriters Laboratory, which is US, so it's the insurance-driven standards. So anything in the US has to be from a plug socket to
they go and
like
blow
their
it up
British
somewhere
standard
and take a photo of it. Yeah.
So they have concentrated on developing a standard for the build of BESS systems, and they have got 4 levels of test, and part of that is the fire suppression system. So a great way to hang your hat on something is if it conforms to that UL standard. So I think
we should put these. Are these free? Can people read these for free? Can we put links in the show notes to anybody who's interested?
Yeah, there will be. Yeah, you can access them online, but I think some of them you've got to pay to download.
Brilliant.
But they are free to view online, I believe.
Okay, that's good. That's good.
But yeah,
classic. Make a really important fire specification and then make everyone pay to see it. What a nonsense!
I mean, it's in its 4th derivation, I think now it is UL, and the amount of time that's spent on it, and it's a constantly moving program.
Yeah.
It costs an absolute fortune to fire test to these.
Okay, so maybe they do have a good reason to charge.
Yeah,
for it,
and once they've got a standard, it tends not to change too often. So usually British standards every 10 years. But if you get a technology like batteries that are moving so quickly, it demands far more change.
You're just iterating and iterating and iterating. Yeah.
So fire systems now should be looking to have performance standards and designs ratified to UL.
So we've got a couple of key ones to look out for there. So there was an NFPA something or other.
NFPA 855.
And a UL one with an A on the end.
It's either 954A, 954A.
Well, this is the problem. If you got that wrong, and we've got people building things to a hairdryer standard. All right. I want to give you a chance now. Anything else you want to talk about, or anything you want to plug? Because we've covered a lot of ground here. I want to say thank you for coming on and having a reasonable conversation about this, because there's a lot of scaremongering.
There is a lot of scaremongering.
And actually, fire-related companies have actually, the cynic in me would say, have got a stake in shit in that, right?
Keep people frightened.
We've had a very, very normal, rational conversation today. So, over to you. Anything else you think we should talk about that we haven't mentioned, or you want to plug?
I think from our perspective, we always operate from a risk assessment. And whilst we have lots of different products, there are certainly ones that are better than others. And what we look at on the prevention side, which is the most important, is a product we call Lion Tamer. It's globally
Lion Tamer. Oh, how exotic!
A US product manufactured by Honeywell, and we, as well as manufacturing our own equipment, distribute for other key product manufacturers. And that's one of our products that we would offer.
So can we get a lion tamer on our battery? Is that what you're saying?
Absolutely. That's the sniffer. That's the bit that will hopefully prevent thermal runaway from occurring.
Okay, so you heard it here first. Get your lion tamers, your sniffing lion tamers on your batteries, and you guys can help people out with that.
We can indeed, yeah. But the second phase of that is detecting thermal runaway and then starting that containment and control process. And the product we use, again, we don't manufacture, it's US manufactured product.
Please tell me it's got a better name than
It has got a Statex.
Statex. Which is... I'm not sure it's as good as lion tamer.
No, it's not as good. We'll go for the leopard tamer next. But the product has been tested independently by both DNV and TUL by laboratories, and it's been proved to contain, and in some instances, because you can never guarantee to extinguish it. So, and then the third is we would use water mist. So it's to consider this 3-stage process, get your insurers involved to discuss this, to see what they'll be happy with, because they may just be happy with one of them if they quantify the risk loss to them adequate. So early conversations all the way around, build it into the specification, because what we're finding is fire systems are left as the poor cousin at the end, and the price and cost comes as a shock.
Yeah. So you've got to lion tame it, so sniff it, Statex it,
sniff it, contain
it, and then mist it.
Yeah.
Easy. Bish, bash, bosh.
Easy done.
All right. We're going to leave it there. I want to say thank you so much for coming on face to face, driving all this way to Birmingham.
It's nice to see people face to face again, isn't it?
Yeah, it's fantastic. And for anyone who's watching or listening, do let us know what you thought of this conversation. There'll be some links in the comments so you can find out more about what we've discussed. And see you next time.
Thank you.